Welcome back, Trigonometry. This is Mr. Carlson, C-Squared Mathematics. And now what we're going to be doing is the last two lessons of Unit 2. So 7.1, Law of Sines, and then 7.2, Law of Cosines. I know this is Chapter 7, but because they are very analytical in nature, I decided to put them with Unit 2 because Unit 2 is called Analytic Trig. So we're going to be finishing the Unit 2 with these two lessons. And we're going to be taking the Unit 2 test this week with, of course, a review day. And then we're going to jump into next week, Unit 3, going through polar coordinates and vectors and polar graphs. So 7.3 is what we're going to be starting with, and that is polar coordinates. So what does that mean? I don't know. I guess we'll have to find out. But today we're going to be going through 7.1, Law of Sines, bell work, objective, essential question, and then the lesson summary and closure. So for bell work, what are we going to be doing here? I have these two questions concerning the bell work on 6.5 trigonometric equations, just a slight review. So this first one is not as bad as this one because this one has a double angle in there, and so we may have to use an identity. But this first one is actually very straightforward, so let's solve that. I'm going to first add the two over. I want to isolate this. So 6 times tangent squared x equals 2. Divide by that 6, of course. That goes poofy. This becomes tangent squared x equals, and then 1 all over 3. When I square root this, when I take a square root, I must add a plus or minus. That's very, very important to the solutions that we're about to get. And then, of course, I'm going to jump right here. When this is finished, this actually becomes radical 1 all over radical 3, which is just 1 all over radical 3, which reduces down to, after I rationalize, radical 3 all over 3. Now, this is not my answer, okay? This will, in fact, give me my answer. So x equals the inverse of tangent of plus or minus radical 3 all over 3, okay? Now, the particular thing about this example is that it does have a plus or minus. And because tangent's period is pi, you're going to actually see a lot more solutions than you normally would. So if we go to our unit circle, first of all, I just typed in my inverse tangent of radical 3 all over 3, and I get 30 degrees. So I do know 30 degrees is one of my answers. It's very basic, and it's right here, as we can tell, if I go to 30 degrees. And I know that tangent is y all over x, so 1/2 all over radical 3 all over 2 is, of course, the 2's go poofy, just 1 all over radical 3, which is radical 3 all over 3. Now that's very simple, and I know pi over 6 is one of my solutions. So I'm going to actually go over here and do pi all over 6. Now I don't need to do plus pi times n because I have 0 to 2 pi, right? So I don't necessarily need to do that. I already have I'm already going to give you all the solutions in 0 to 2 pi. I don't need to do anything more than that. I don't need to add the plus pi n. Okay, I'm just going to list them out just like normal. Now, I also have a negative, so I'm going to go over here and do a negative. And you'll see that I have negative 30. Now, negative 30 is not really an angle, but negative 30 is right here, which is 11 pi all over 6, or 330 degrees. Now, why is that, Mr. Carlson? That's a great question, kids. I have this right here, so negative 1/2 all over radical 3 all over 2. Very similar to what we did here, and it will give me a negative radical 3 all over 3. So I do know 11 pi over 6 is one of my answers as well, so I'm going to go over here and do that. Now, the tricky thing about this particular problem is that there is actually 2 more. Okay, because they tell you, and it's tangent, because they tell you it's 0 to 2 pi, because of the nature of tangent, it's every pi integers. If it didn't give us an interval, we'd actually be done here. Okay, because then all we would have to do is just plus pi n onto both of these and be very just done. Like we wouldn't have to do anything else. Okay, but because it does give us an interval between 0 to 2 pi, we do need to kind of use our mind a little bit and think about where else on the unit circle does it give me a negative radical 3 all over 3 or a positive radical 3 over 3. And sometimes that's a little bit tricky to understand or try to figure out because they don't give you tangent on the unit circle. They only give you sine and cosine, the x and y coordinates. But they are here, and they are as follows. Okay. Now, we already had this side of the unit circle. We were given this side of the unit circle when we just plugged it into the calculator. Now, why is that? If you remember from 5.7, if tangent, if we're taking the inverse of tangent, they only give us the right side of the unit circle. Okay, the calculator only calculates the right side of the unit circle because that's what makes the trig function an actual function. But if I want all the solutions from 0 to 2 pi instead of from negative pi over 2 to pi over 2, that's what it was in 5.7. If I want 0 to 2 pi, all the whole circle, I need to include other solutions that I wouldn't normally include in this calculation. Okay? So how do I find that? Well, there's an easy way and a hard way to find it. The hard way to find it is just literally dividing these and just guessing and checking. And of course, this does work out to become negative radical 3 all over 2. However, the easy way is just to use your trig table of common elements, common angles, really. So I look at tangent, I find radical 3 all over 3 right here. So in this box, and that is pi over 6. I also find it here, the negative radical 3 all over 3. 5 pi over 6, that's one we don't have. Positive radical 3 all over 3. 7 pi over 6, and then negative radical 3 all over 3. 11 pi over 6. So I do have 4 all the way from 0 to 2 pi radians. Okay? And that's totally within my bounds to do it. So I need to include all of them. So what am I missing? I'm missing the 5 pi over 6 and the 7 pi over 6. So let's go ahead and include that into my interval. So 5 pi all over 6 and then 7 pi over 6. And then I'm done. Now again, I don't need to put down the plus pi n because I'm solving within an interval. I don't need to do that if I'm solving within an interval. If this was not here, then yeah, absolutely, I would have to. But it is there, so I don't need to. Another easy way to do this is, you've guessed it, just using Desmos. Okay, I can plug this into Desmos. I just don't put the equal 0 here at the end. I just put the regular equation and then the restriction. And then, of course, you'll see that these are my answers. Voila. Okay? That's the easiest way, I think, to do it, other than using the trig table of common angles. The hard way is really just using the unit circle and trying to piece together everything that you're given. Maybe in tandem with your calculator right there, but it's still pretty difficult. Okay? So I hope that helps. Let's erase this and let's get to the other one. Now this one is a little bit more tricky just because it has cosine of 2x in here. So what's cosine of 2x? What is that? Well, they say use an identity, and I know that this right here is a double angle. What's the formula for a double angle? So there's actually multiple different formulations of cosine of 2 theta, or cosine of 2x in this case. And one of the most used ones is this. This actually equals cosine squared x and then minus sine squared x. This is one of them, but how would that help me? If I put sine in here, how will that remotely help me? I mean, I guess it could help me because I could do sine squared x right here to be 1 minus cosine squared x. I mean, that would be very gross, right? Because then you would have to just do a lot of arithmetic, and it would just be really annoying and blah, blah, blah. You could do that way, where you can do a substitution within a substitution. So you can say, okay, I'm going to substitute this in for cosine 2 theta, or cosine 2x rather. And then you're going to say, okay, I'm going to now substitute 1 minus cosine squared x, my Pythagorean identity, to do this in substitution of this, sine squared x. You could do that, but it's kind of annoying. It's like a substitution within the substitution. A better way to solve for is to recognize that another formulation of cosine of 2x is this, 2 cosine squared x minus 1. Now, the reason why that is because it comes from this formulation. So if I actually did do this, guys, watch this. This is actually really crazy. If I did this, and then I substituted in 1 minus cosine squared x, and if I just substituted that all in right here, yes, what I would really get is That would be a minus, sorry, minus 1. I really get 1 cosine squared, 1 cosine squared, which is just 2 cosine squared x, and then plus a negative 1, which is minus 1. But that's exactly what we got there. So either way you do it, you could do it this way and then another substitution, but then you get to the exact same thing no matter what, right? So just recognize that you have multiple different identities for cosine of 2x. How do I know that? Great question, kids. If you go over here and you scroll down to your trig table or trig formula sheets and you go to your cheat sheet. Now, this one right here, if you scroll right about here, notice this. You have this one and this one. Okay? But you also have this one. And that's if I plugged in, instead of cosine, 1 minus cosine squared theta for sine squared theta, if I plugged instead 1 minus sine squared theta for cosine squared theta. I'm just using my Pythagorean identity, just vice versa, no matter where I want it, no matter what I want to use for it. But they all mean the exact same thing, and it's provable. So what I'm doing is I'm actually just taking this one, but you could do that, but you'll still get here no matter what. Okay? So I'm just kind of cutting out the middleman, as it were. So that's what I'm going to do. So now watch. I'm going to substitute this thing right in for cosine 2x. Okay? If none of that made any sense, I would be very sad because I think it's awesome. But just notice there's multiple different variations and formulations of the double angle. And I'm going to use the one that doesn't give me 2 different trig functions. I'm going to use the one that gives me just one trig function, namely cosine. So I'm going to substitute that in. This is 2 cosine squared x minus 1. This is plus 9 cosine x plus 5 equals 0. Perfect. Now the negative 1 and then the plus 5, I can do that. So let me just get to it. So this is plus 9 cosine x, and that's actually going to be plus 4 equals 0. Now when I get here, I am going to do a slight divide and slide. So I'm going to take the 2 and times it to the 4. So 2 times 4 is 8. So factors of 8 that somehow, some way add up to 9. That's just 8 and 1. So now what I'm going to do is I'm going to do my basic template, cosine x. And this is going to be plus 8 times cosine x plus 1, and then equals 0. And now what I'm going to do is I'm going to divide by my leading coefficient here, which is 2. So divide by 2, divide by 2. So this right here is cosine x plus 4. And then this is actually cosine x and then plus 1/2. Now I know what this will equal is just straight up cosine x equals negative 1/2. That's simple. But look at this one. This one will be cosine x minus 4. But here's the question. Does cosine x even have a range of negative 4 to whatever? No. This will equal negative 4. Okay, cosine at the very, very bottom here. Sorry, the very, very bottom, cosine of x equals negative 4. But that's totally out of my range, so I don't actually care about that one at all. This one, however, is within my range, is within negative 1 to 1. So I am going to do it. So how do I do that? Well, there should be 2 solutions here. Let's use the unit circle to find out because I am wanting to find 0 to 2 pi. So where does cosine of x, what angle gives me of cosine negative 1 all over 2? I go over here. Well, negative 1 all over 2 is right here. But that is sine, so never mind. for cosine, right here. So 4 pi over 3, and then right here, 2 pi over 3. And notice all students take calculus, so it can't be here because cosine is positive in the first and fourth quadrant, so it can't be there. However, it can be in these 2 quadrants because only sine's positive here, only tangent's positive here, which means cosine is negative in both. And true, negative 1/2, negative 1/2. So my answers, 2 pi all over 3, 4 pi all over 3. 2 pi all over 3, 4 pi all over 3. Let's go over here. 2 pi all over 3, and then 4 pi all over 3. Those are my 2 answers. Okay? Done. Perfect. Fantastic. So that's the bell work. I'm not going to spend any more time on that. let's erase and let's get started on the actual lesson. So the actual lesson, law of sines. I love the law of sines, but there's one particular thing where it's very difficult for students to understand. If you're thinking it's going to be more difficult than 6.2 or 6.3 or verifying trig identities, it's not. Okay, it's very, very simple, very logical actually, just plugging in formulas and stuff. What makes it difficult is one thing, I'm going to show you that towards the end. But so far, what we've really been doing is just right triangles. So now we're going to actually introduce non-right triangles, or what we call oblique. So hopefully by the end of the lesson, you can solve SAA, ASA, and SSA triangles by using the law of sines. And then hopefully you can find also the area of an oblique non-right triangle. So how can I use the law of sines to solve and find the area? Solve and find the area of an oblique non-right triangle. So up to now, like I said, so far what we've been doing is really just been limited to right triangles. You notice that? It's all been limited to right triangles. We started with right triangles, then we introduced the xy plane to the right triangle, and then we solved it on any angle. Then we solved it on any real number using the unit circle. And so not just on any angle with any quadrant, but any real number. We saw that sine was x and cosine was sine was y and cosine was x and tangent was y all over x. And then we also went a little bit further and solved identities. We looked at identities and said, okay, this is true no matter what. We use specific identity formulas, so 6.2, sum and difference, and double and half angles. And then we also looked at multiple angles and how can I solve a trigonometric equation using identities, using trig on any angle, using our graphs. We did that in 6.5. And finally now, given all of that right triangle junk, what if we don't have a right triangle? That's what we're going to be asking today. What if we don't have a right triangle? Can we still solve for the triangle? And the answer is most fortunately, yes. Okay? So these are what we call oblique triangles, and they're going to be as follows. So non-right triangles. Okay? So here's the formula. If A, B, and C, capital, are the measures of angles, are the measure of the angles of the triangle, and lowercase a, b, and c are the sides opposite of these angles, respectively, then we can actually solve this thing using this proportion. Now, I'm going to be very clear here. If we're not solving, when we solve it, we're not going to use every single piece here. Like this is the first piece, that's the second, and that's the third. We're not going to use every single piece. Actually, we're going to be using just two pieces at a time. So sometimes we may be using these two pieces. Okay? Sometimes we may be using in red these two pieces. And then sometimes we may be using in green just the A piece and then just the C piece. Okay? But does it matter? No, because they all equal each other, which is fabulous. Okay, they all equal each other. So we're not going to be using all three pieces. We're only going to be using two pieces at a time, but maybe A and B, B and C, A and C, and so forth. Okay? So let's erase that and let's get to our first example. Oh, that's also another very, very important note. You have to be at least given three parts of the triangle in order to solve. But, I mean, that should be very evident because I think we should already know that. Because we solved right triangles before, right? And we had to have at least three pieces of the part, three pieces of the triangle in order to solve. So that's kind of a review, I hope. But even in geometry, you needed at least three parts of the triangle to solve. Same thing here. Here are the steps, and I would highly encourage you to write these down because this lesson is a highly integrated steps lesson. Like I'm going to almost follow the steps exactly. I perfected these steps, and I feel like they're the best. So this first example. In this first example, I have the first step, set up a proportion using the given matching side angle pair. So I'm going to say that again before I finish the whole step one. Set up a proportion using your law of sines given the matching side angle pair. And then after that, the given angle with its missing side. Okay? So after that, you're going to solve for the missing side. And then you're going to solve for the missing angle because you have three other things that you need to solve for. And then, of course, you're going to set up and solve after that the proportion using, again, the given matching side angle and the new angle with the other missing side. Okay? Are we ready? So this is what I'm given first. Actually, move my little face up here. Probably going to be better. So this is what I'm giving first. Okay? SAA triangle, when I have a side angle, so a side right here, C equals 56, A equals 46, and then C equals 63. When I'm given all of this junk, I have an SAA. Now, the first step is going to be as follows. I'm going to set up a proportion. Now, what am I actually going to be using? I'm going to be using, first of all, the given matching side angle pair. So I'm given C, the angle and the side, okay, and the given angle with the missing side. So the given angle, A, with its missing side, A. So what am I going to actually be using? I'm going to be using this portion of my sine, of law of sines. So I'm going to write that down. So I'm going to be using this. Okay? Now that I'm going to be using that, let's start plugging in. What's my side length A? I don't know that. Okay, I'm going to solve for the missing side. That's what I'm doing right now. Okay, so step 2, I'm actually solving for this missing side here. All right, that's really what I'm doing. So actually, this is step 2. I'm solving for the missing side. I'm setting up a proportion. Step 2 is I'm solving for the missing side. So this is all over sine of A, which is 46 degrees, equals C is 56 inches, and this is all over sine of C, which is 63 degrees. Okay? Now, when I actually solve this, I solve it like a proportion. So you'll see me solve this, and I'm actually going to go pretty fast on these. But really what this is A times sine of 63 degrees equals, that degree symbol is obnoxiously big. Sine of 63 degrees, that is even worse. What is with my degrees today? Okay, that's a little bit better. Equals 56 times sine of 46 degrees. Now, if I want to solve for A, what I do is divide by sine of 63. Sine of 63 is a number. So I can actually do this. I can divide by sine of 63 degrees without even calculating it. So now what I have is A equals all of this. 56 times sine of 46 degrees all over sine of 63 degrees. Now what does this actually equal, like approximately? This, at this point, this is when you use Desmos, okay? Or your TI-36X Pro. Because you don't need to solve like 63 first, sine of 63 first, and then what's 56 divided by sine of 46, like, or 56 times sine of 46 divided, like, you don't need to do it in chunks is what I'm saying. You can do it all in one straight up chunk. So let's go to Desmos and actually type that in, okay? Let's erase this. First of all, let's make sure we're actually in degrees. Okay, that's the first thing. Make sure you're in degrees. So let's actually solve this. I want A equals, and this is, I'm just going to type it in exactly how I see it. This is 56, and then sine, and then we have 46 degrees, divided by, and then sine of 63. Now what I get is 45.2. So I'm gonna do that. I'm gonna go over here and just type in 45.2. So that is my A value. So equals 45.2. Perfect. Okay, now that I have that, and technically it is inches. I mean, if you really want to get technical, sure. Okay, now that I have that, I'm going to do my step 3. My step 3 is solving the missing angle. So what's the missing angle? I mean, now that I have all of this, I have 46 63 in this, all I have to do is just subtract by 180. So actually, let me do this a little bit more formally. So B is the missing angle. I don't know that. Okay, so I'm going to say B equals 180 degrees minus 63 minus 46 degrees. And then minus, nothing. This equals. I'm thinking like another degrees. I'm like, no, it's just 2. So this right here, 63 degrees. This is my C, that's my A, and then I just need to find my B, right? I don't know that. So let's find out what it is. What do? I just go to Desmos, of course. So 180 minus 63 minus 46. So 180 minus 63 minus 46. So 180 minus 63, then minus 46, and I get 71 degrees. Okay, so this is at least, and we can even label it and make it all cute. So B actually equals 71 degrees. So I can go over here and say that B equals 71 degrees. Perfect. Found my missing angle. And now what I want to do is my fourth and final step. Solve the proportion again to find your missing side length, which is just lowercase b. So I'm going to do b all over sine. What I just found for sine of b, my angle measure, is 71 degrees. So I have to use that. And now I want to use I'm not going to use a here. And the reason why I'm not going to use a is because what if I got a wrong? And if I put a right here, I get that wrong too? Okay, so what I want to use is actually my given angle slash side length, my matching angle and side length. That way, at least if I get A wrong, I know I more than maybe get B correct. Okay, because if I can easily subtract 180 or these things from 180 to get B. So more than likely, I'll get this one right, even if I got A wrong. So that's just a helpful tip in your Math Excel, and even test taking really, is always use what you're given. Okay, always use what you're given. So I'm going to be using my C's here, not my A's. Okay, my C's. So sine of C or sine of 63 degrees. And that way it's just easier. So this, I'm just going to jump right to the proportion. When I actually cross multiply and then divide, something very similar to this, what I got here, I'm going to get here, and that is B equals 56 times sine of 71 degrees all over sine of 63 degrees. Okay? And this is actually probably going to be an approximation, so let's do that. So what's the approximate? What does B approximately equal? Let's find out. Let's actually plug that into Desmos real quick. Okay? So I'm going to do B equals, I have 56 sine of 71 divided by, I have sine of 63. And what I get is 59.4. 59.4 for my B. And those are my 3 missing sides. I have them nice and neat right here. Isn't that great? I have them nice and neat right here, 59.4. I go over here and I just type in 59.4. And yes, technically it is in inches. So what do I got? I got my missing side length, my 2 missing side lengths, and then 1 angle measure, given the fact that I had 1 side length and 2 angle measures. Okay, and they're all right here. My 2 side lengths and 1 angle measure. And that's it. I solved for this whole triangle. Boom, boom, boom. Okay? Not too terrible, right? Law of sines is actually very, very simple when we actually understand it and kind of go through the proportions. So let's erase this. Let's go through another one. Now we're going to go through, what if I have an ASA, an angle side angle? So notice right here I have an angle and then the side in between those 2 angles, so angle side angle. So are the steps going to be basically the same? Well, sort of. They will be, but just a tad bit different. So first of all, find the missing angle. Okay, that's probably the easiest thing to do. And we could have done that first in our last example too. I just didn't put it like that in the steps. It doesn't really matter if you found the missing angle first in the last example. But in this example, I'm going to find the missing angle first. Then I'm going to set up and solve the proportion with this matching side angle. We don't have a real matching side angle here, okay, which is kind of unfortunate. Well, I guess, yeah, we will have a matching side angle once we find the missing angle. Okay, so that's why this one has to be first, because I don't have a matching side angle so far. I mean, C, don't have a matching, B, don't know what that is, and A, don't know what that is. But if I found B, at least I would have B to be the matching side angle, and then one of the other missing uh, sides with another matching angle. Okay, and then repeat it. And then, of course, just as a reminder, we want to always use what's given to us when we kind of go through these law of sines. Because if I mess up in one area and I keep using what I'm finding instead of what they're giving me, I could potentially uh, bankrupt myself in poor mathematics, as it were. Okay, so what am I actually going to use? My first step is actually going to be down here. Okay, because I want to find that missing side, that missing angle. So what is that? Well, that's just 180 minus 50 degrees and then minus 33.5 degrees. This will give me B equals, and you can do this on Desmos real quick if you want to. I'm actually just going to tell you it's just 96.5 degrees. But that's how you would do it. You would just go on Desmos and do that. So that's my first. My second step is going to be using that. So I'm going to be using my side length B and then sine of B. And then I could use A or C here. It really doesn't matter. I'm just going to solve for A, I guess. So I'm going to use my side length A and then sine of A. Okay, it doesn't matter if I did my A's or my C's, okay, because they both don't have a matching side angle. They both are missing something, okay. But I do need to use B, absolutely. So let's do that. My side length B is 76 all over my newly found best friend angle, sine of 96.5 degrees. So that is what I have there for B. Now my A, I don't know what my side length A is, so I'm going to keep it right there. And then sine of A is 50 degrees. So I'm going to do that. Okay. Now when I cross multiply, I do get this. I'll show you this one last time just in case you're confused. But I really don't want to take up the room to show this to you because it is just very basic proportions. And then I divide by sine of 96.5 degrees, divide by sine of 96.5 degrees. Okay, so I just divide by that, and then that goes poofy, and I'm left with A equals. Most of the time, from here on out, I'm actually not going to solve that step. I'm not going to show you that step. I'd rather just jump here. What is A if A equals 76 times sine of 50 degrees all over sine of 96.5 degrees? What is A equal? So let's go to Desmos to find out. I'm going to show you just one last time what's going to happen if I go to Desmos and plug that in. So since I already have A right here, let's just adjust this, okay? Let's just adjust it. This is going to be 76. I scroll over. I don't want 46. I actually want 50, not 550. And then I don't want 63 down here. I wanted 96.5. So what does A equal? A equals 58.6. 58.6. I'm going to round that. 58.6. So let's go over here. 58.6. And then they don't give us inches or anything like that. So that's what it equals. Perfect. I already know that B is that. And now my next thing is my third step. My third and final step is repeat for the other side. So now I'm going to be, I don't know C, right? So I don't know C. So I'm going to be using sine of C. I do need to find that. And I'm going to be using the exact same thing that I did as B. Okay, I'm going to be using the B here that I found. Okay, so that means 76. Actually, to keep it with the formula, I'm going to use B. So B all over sine of B. So I have that. Perfect. So that means C, I don't know that. Okay, but I do know the angle measure, and the angle measure is 33.5 degrees all over, or equals, and then what the junk is next? My B. So I'm going to just type in my B. So my B is 76. Holla. And then this is 70, a sign of, whatchamacallit, what is B? 96.5. 96.5 radio show. I do the exact same thing, proportions. So this is going to be C equals, when I solve this, this is going to be 76 times sine of 33.5 degrees all over, and then sine of 96.5 degrees. So I found two parts of my triangle. I'm trying to find the last part, and that's the side length. Okay, I can't use Pythagorean theorem on it, right? Because it's not a right triangle. So I need to solve it doing that way. Let's go to Desmos real quick, and let's type that in. And so let's actually just erase this. Let's do C equals. Let's type in our last thing. This is 76 times sine of 33.5. Now notice I'm still in degrees. Okay, make sure you are in degrees as much as possible. And just to double check, I'm in degrees. What is C? C is 42.2. 42.2. So I go over here and I just type that in, write that in. 42.2 inches, meters, feet, doesn't matter. It doesn't tell us. Okay. So I found them all. And of course, because we need it, an awesome unicorn. Okay. He looks very happy, I think. Very, very happy indeed. So that is how I solve ASA triangles using the law of sines. Okay? Sweet. So let's erase that and let's get to the harder examples of what we call the ambiguous case. So what is the ambiguous case? It's when we are given SSA triangles. They are a real pain in the butt. You get it? You get, okay. So they are a real pain in the butt because they give us what we call the ambiguous case. Now, what this case is it really just gives you an odd sort of, you don't know sort of thing to solve for. It's very unclear. Is it one triangle? Is it two triangles? Is it a right triangle or is it no triangle? So when you're given two angles and the side of an oblique triangle, two angles and a side of an oblique triangle, it is pretty straightforward. However, when you're given one angle and two sides, the situation becomes very ambiguous. So before we were given two angles and then just one side. We had ASA or AAS. That's what we did before in the first two examples. But now what we're going to be solving for is two side lengths. We will be given two side lengths and one angle. It just becomes very unclear. And here's why it becomes unclear. So try to pay as very close attention to me as possible. This is why it becomes unclear. You can have one triangle. So this is the first thing that you could have. And why is that? So if A is greater than H, and H is B times sine of A, and if A is greater than B, then one triangle is formed. So they kind of have what we call these tests. So down here, if you want to write this, this is what we call these tests. And we will be testing these out in the next coming examples. We have to test them out to see whether or not it's one triangle, one right triangle, no triangle, and so forth. You can't just blindly solve these. You need to know if there's one triangle, no triangle, or whatever. So these are what we call tests. And the first test is if it's one triangle, I'm going to test to see if A is greater than H, or I can substitute because H is equal to B times sine of A. If A is greater than B times sine of A. And at the same time, A has to be greater than B. So these are the tests. This is the two tests for one triangle. Okay, this is the two tests for one triangle. Now, if it's a right triangle, one right triangle, the second thing that I could possibly get out, okay, it's if A equals H, your height right here. And again, h is b times sine of a. So if a just equals, if a equals, that side length a equals b times sine of h. That's the only test that you have to do there. And that's actually nice, right? You don't really need to do any other thing. Like here you have two tests. These both have to be true in order for it to be one triangle. Okay, this it only has to equal it, and so that's nice, right? Now in the next one, you can have, in purple, you can have, my third possible solution is no triangle. And this is the best, right? Because you don't even make it after the test. You don't even need to solve anything. Because once you get through the test, if it doesn't check out, then it's no triangle. Or if it passed the test, then it's no triangle. So h is still b times sine of a. H, the height, is still b times sine of a. What is that? Well, that's if a is less than b times sine of a. Or if a is less than h here. Okay? That means that side length, h, the whole height, is just not long enough to form an actual triangle. Okay? And those are the best. Okay? And we will go through one. And sometimes you will have one on like your test. So just FYI. And then lastly, probably the hardest, the most difficult, when you have two triangles. And you have to solve for two triangles simultaneously. And here you can have one triangle that's like this, but you can also have another triangle, a much larger triangle, that goes like this. And this is what makes it so difficult. Like you can have one triangle like that. Okay? Or you can have one smaller triangle just like this in green. And that's what makes this one so difficult, because you have to solve for two at the same time. So this is b times sine of a. So what is this? If a is greater than h, or b times sine of a, and a is also less than b. So if a is also less than b, if those both check out, then that means we have two triangles. Okay? So I'm going to go through each one of these, except for probably the one right triangle, because I feel like that's pretty straightforward. We know how to solve if it's a right triangle. I mean, it's going to be very easy. I am going to go through one triangle, no triangle, and then two triangles. Okay? Let's go first through one triangle, see what that actually looks like. Okay, here are the steps. Steps. First, determine how many triangles. Is it going to be one triangle? And I put the test here for you. So this is the first test. Here's the second test. Is it going to be one triangle? And if both of these tests, a greater than b times sine of a and a greater than b, if both of those work out, then yes, it's going to be one triangle. Is it going to be one right triangle? Is it going to be no triangle? And is it going to be two triangles? So obviously this example 3, is going to be one triangle, right? I'm not going to try to confuse you there. But when you get an actual question on the homework test or whatever, they're not going to tell you, hey, it's one triangle, solve one triangle. Okay? They're not going to tell you that. You need to actually test it out yourself. And I'm going to show you what that looks like. Second step is set up and solve the proportion using a matching side angle, just like what we did before in the previous two steps. And then find the other side with the missing angle. Solve for the last missing angle. Set up and solve the proportion for step 4 using the matching side angle and then the other angle with the missing side. And then, of course, as a reminder, always use exact given sides no matter what. Here's what I'm given. I'm not even given a triangle. Okay, I'm just given side lengths. Oh, geez. Oy vey. Okay, let's get started. Now, I already know it's going to be one triangle, but let's test it out, okay? Let's test it out. The reason why I already know it's going to be one triangle is because I literally tell you it's one triangle, okay? But let's test it out anyways. This is my first step. Are you ready? So watch. This is my first step. I'm going to take A. I'm going to follow this right here. What's my A value? It's 81. So I'm going to take 81. Is this greater than B, which is 62, times sine of A, 43 degrees? Does this check out? Let's find out. What's 62 times sine of 43? Let's go over here to find out. 62 times sine of 43 3. So 62, and then sine of 43. This is 42.2. So that means, does this check out? Yes, it does. So that means 81 is indeed greater than 42.2. It checks out. Now, let's go to our second test. You see how long this would probably take? You're right. It does take a while, okay? Because if this doesn't check out, if one of these is wrong, let me just say that. If one of these is wrong, if that one did not check out, I don't need to bother with that one. Do you understand? So if this one didn't check out, and if this was like 90 degrees or 90 whatever, if this, let's just say, was 90, I got 90 instead of 42.2. That means clearly 81 is not greater than 90, which means that wouldn't check out, which means that wouldn't check out. And then I would just say, okay, it's not one triangle. Let's go and see if it's one right triangle. Does that make sense? Okay, so since the first one, though, did check out, A is greater than B times sine of A, 81 is greater than 42.2, that means I have to check to see if this one checks out. Now, if this one, A, is not greater than B, then it's not one triangle. I move on to see if it's one right triangle. I hope that makes sense. So A, 81. Is 81 greater, B, where's my B? 62. Is 81 greater than 62? Well, of course it is. So that means this also checks out, which means it is one triangle, which means I'm not going to go through this one. I'm not going to go through that one, and I'm not going to go through this one. I only want to go through that one. It's one triangle. Let's solve it as such. Does that make sense? Awesome. So now what I'm going to do is I'm going to start solving this triangle. I'm going to use what I'm given. I'm given a matching pair of A, so side length, and angle. So I'm going to use that, of course. So 81 all over sine of 43 degrees equals. Now, I don't know B, so let's just solve that. Like, I want to find the missing angle, right? So I'm given side length B, 62, but I don't know sine of B. How do I solve for that? Well, when I cross multiply, what I'm actually going to get is sine of B equals, I'm going to get 62 times sine of 43 degrees all over 81. That's what I'm going to get when I cross multiply and then divide by 81. Now, of course, this is not solve for B, so how can I actually solve for B here? Well, B equals the inverse of sine of 62 times sine of 43 degrees all over 81. So this is what I'm going to plug into my calculator. That is what I'm going to plug into my calculator to get B equals. Okay, so this one's a little bit different because we have to use inverse functions here. Instead of the last two examples, we didn't use any inverse functions. But now I need to use inverse function. Let's go to Desmos to find out what that is. So let's actually just go through that because this is already 62 times sine of 43. So let's do B1. Actually, let's just do B equals. Oh my gosh. Let's erase this B though. It doesn't really. Well, let's just erase all this jazz because we don't really need it. That's from the previous examples. And then this actually equals this inverse sine. So I'm going to do the inverse sine in parentheses. Okay, notice what's happening. Now, of course, it's undefined because I haven't solved anything yet. I need to do over 81. And then, boom, that is what I have. Okay? Perfect. So what does this approximately equal? 31.5? About 31.5. And that's how I solve it. So I go over here. First of all, it's an approximation, so let me erase my equal signs. So it's approximately 31.5 degrees. Perfect. I found one of my pieces. Okay. Now my third step is to basically continue this strand and find my other missing side length, or sorry, my other missing angle. And so that's my third step right here, solve for my last missing angle. So that's what I'm going to do. My last missing angle is C. So let's do C equals 180 minus, and then this is going to be 43, and then minus 31. 0.5. Okay. If you want the exact value, which Math Excel will more than likely want the exact value, here's what you do. Okay. You go over here, you go to Desmos, you see that that's B, right? So you say C equals 180 minus, and then I had 43, and then minus my B value, and all I have to do is just say B, and then boom, that's what I get, right? That's pretty cool, right? So that's really what it is. Depending on what what Math Excel wants you to actually round to, do whatever. But right now, it doesn't tell me to round to any decimal place. So I'm trying to be as exact as possible. And so that way, it does give me the exact value, 105.5, and I'm just going to round it there. So C equals 105.5. Let's go over here and write that in. So 105.5 degrees. That's what C equals. That's my missing angle. Now, let's find my fourth and final step. Let's find my missing side length. Okay, I want to find my missing side. All right, I found my angles. I have all my angles, but I need to find C. So what am I supposed to do? Well, first of all, use what you're given. I'm given the matching pair of A, so I'm going to continue using that. So 81 all over sine of 43 degrees equals. What is my C? I don't know my C, but I do know my angle C. I don't know my side length C, but I do know my angle C, which I just found, 105.5. Now, the cool thing about this is that now you can actually use this in Desmos. I'm going to show you, and you can get the exact answer always. So watch this. So this is going to be C equals. This is C equals. When I multiply, cross multiply, and then I divide, what I get is 81 times sine of 105.5 degrees all over, and then this is sine of 43 degrees. Now you can plug this exactly how you see it on Desmos, and you'll get a similar answer, probably the correct rounded answer. Or watch what I'm about to do here. Let's go to Desmos, and I'm going to show you how to find this side length C. So I'm going to find lowercase c equals, ready? I have 81 and then sine of 105.5, which is capital C. Okay, so notice what I'm doing here. I'm actually taking what C equals and I'm putting it right into a next line, so it gives you the exact decimal. Instead of, if I rounded, watch, if I just put this as 105.5, it's not going to be 78.0419. It's going to be 78.05406. Like, it's a little bit different. So if you want the exact, just label them on Desmos when you're solving this, and you'll be fine. I still need to divide, though, by sine of 43. I still need to divide by sine of 43, just like what I did here. And so now that I did that, making sure I'm in degrees, which I am, what is my lowercase? It is 114.4. It's 114.4. And that is the most exact you can get. My side length is 114.4. I'm done. That is how you solve one triangle, and using Desmos very effectively at the same time. Okay, perfect. So I got 3. I was given 3. I found my other 3 parts. I found my other 2 angles, and then I found my missing side length. Notice my angles are in degrees, so I know it's my angles. And my missing side length is not in degrees, which tells me it is my side length. Awesome. Let's erase this, and let's go through. Let's go through no triangle. What if I have no triangle here? So this one's going to be very simple because I already know it's no triangle, but I'm going to just show you the steps. If I actually, let's just say I wanted to go through this one. If I wanted to go through that one, let's just go through the very first step and see if it's actually one triangle. What's my A value? 51. Is this greater than B, which is 71, times sine of A, which is 75 degrees? So let's try that out. Let's go to Desmos and actually see. So 51 is that greater than 71 times sine of 75? So 71 times sine of 75. 71 times sine of 75. So this is 68.5. Okay? Which means if this is 68.5, is 51 greater than 51? Is that greater than 68.5? No, it's not. Okay, so since it's not greater than, it's not going to be one triangle. You don't even need to test out this other one here. Okay, if it's one right triangle, obviously it's not equal to, so it can't be that. And so since, now watch, so since this right here is actually, watch what this is, since this side is actually the thing that's greater than that side, and since A is in fact less than, since A is in fact less than 68.5, so 51A is less than 68.5, what that means is it tells me that this is no triangle. So you kind of see how you go through each one, and obviously if it's not greater than, then it's not equal to. If it's not greater than, then it has to be either, it has to be less than. So if it's not greater than, it's either equal to or less than. So that means not even two triangles works out. So you can kind of see the progression of what you need to be thinking about when you solve these tests. Okay, so since this is true, that means it's no triangle. So I'm going to use my fancy math symbols here. That means therefore, no triangle. And that's all there is to it, guys. That's all there is to it. This is my final answer. Therefore, no triangle. What would this actually look like? Some may be actually interested in seeing what this would look like. What it'd be looking like is something like this. This is A equals 51. This is C. This is A, and A is given 75 degrees. And this is B equals 71. This is what it would sort of look like. It doesn't form a triangle because it's not big enough. Okay, this side length A is just not large enough to match up with that. Therefore, no triangle. Okay? Perfect. Pretty easy example, right? That one's nice. Man, imagine having one like that on the test. You will, don't worry. Now, the big beast, two triangles, so stick with me. Two triangles. What are my steps? I'm going to go through the steps, of course, just like normal. Here's what they are. Okay? All listed out. Whoopsie, all listed out. But here's the thing. They're a little bit different. The steps are. Now, why are the steps a little bit different? Well, because if it's two triangles, you need to solve a little bit differently. So I have something like this. I still have my determined how many triangles there are. I still have that. I still technically have two. It's the exact same thing. Set up and solve a proportion using the matching side angle and the other side with missing angle. Now call this, though, B1, okay? B1 is probably the easiest I can call that. Actually, I'm going to backtrack here. So I'm going to call that B1. Okay, B1 is probably the easiest I can do, so that's what I'm going to do. Now find the supplement of B1. Call that B2. Now what's the supplement? Can we guess? The supplement is going to be the plus 180. So it's basically looking at 180 instead of 90. The complement is what we call 90 degrees. So I'm going to actually subtract that from 180. That's going to be what we call B2. Now find angles C1 and C2. This can get very complicated, so you need to pay very close attention to my steps here. Find the angles C1 and C2 respectively. So that means respectively means B1 is corresponding to C1. They're part of the same triangle, whereas B2 is corresponding to C2. They are part of the same triangle. Because again, you're going to have two different triangles here, all right? So you need to keep track of the different angles that you could possibly get because you will have a lot of different angles. And then after that, of course, you're going to solve for this, your missing side lengths. And that's going to be C1 and C2, again, respectively. You're going to set up and solve the proportions using the matching side angle pairs that you just found, and then the other angle with the missing sides, C1 and C2, respectively. Okay? You're going to be given something like this. It is a SS. Okay, it's a real pain in the butt. All right. But however, we're going to actually solve it using math. Watch. My first step, let's do our test. What is it? Does our test work? Let's find out. So A, is it going to be greater than or equal to or less than? Greater than, equal to, or less than. So let's just kind of put a blank here. Okay, what's my A value? My A value that I'm given is 54. And then I have A and B. Or sorry, B times sine of A. B times sine of A. So what's my B value? 62 times sine of A, which is 40 degrees. So I'm not going to show that, but sine of A, so 62 times sine of 40, this actually equals 39.9, which means is this A value 54, is that greater than or less than? It's greater than, which means it could be either A, one triangle, or D, two triangles. Okay? Now you have to test it out the other way, but with a straight line. So you have to test it out the other way. So that means you have to see if A is actually less than or greater than. That's going to tell you if it's one triangle or two triangles. So can you feel the anticipation? Is A 40 degrees? Is that going to be less than? Is that going to be less than or greater than 62 degrees? Well, of course, that's less than. So since 40 is less than 62 degrees, unfortunately, you have to bite the bullet and you have to say this is going to be two triangles. So it's not going to be one triangle, not going to be one right, not going to be no triangle. It has to be two triangles here. Okay? So in order to save some room here, actually, you know what? I'm good with the room. I'm just going to do this. Okay, that's my test. Let's go to my actual problem. So step 2, set up and solve proportion using the matching side angle pair. I have that, so now I'm going to do that. 54 all over sine of 40 degrees. Perfect. Equals. And the other side with the missing angle. So B. So I have 62, right? So 62. And I need to solve this using sine inverse. I need to solve it using the inverse of sine, just like in our last couple examples. I had one triangle, but I'm going to call this B1 now. Notice I'm going to call B1. Now, what is this? When I cross multiply, what I have technically, and I'm going to go straight there, guys. I'm going to go straight there, so I hope you forgive me. B1 equals, it'll be the inverse of sine of 62 times sine of 40 degrees all over 54. Okay? So what does this equal? What does B sub 1 equal? Let's go to Desmos to find out. Let's plug this in to Desmos or your TI-36X Pro and find out. Now, the cool thing I like about Desmos is you can actually label the stuff here. And this is what I love about it. You can actually label capital B1 as almost as if you're solving for it, which is really, really crazy. So I have 62 and then times sine of 40 and then divided by 54. That definitely does not seem right. Am I in radians? I'm in degrees. Give me a second. Oh, didn't do my inverse. I was like, what's wrong? What's wrong with this? I need to do my inverse, right? So sine of inverse. Silly me. Boom. There we go. Perfect. Okay. I'm actually going to, let's do 47.6. So 47.6. Let's do that. So B1 is 47.6 degrees. Don't forget your degrees. So that's my first angle measure of my first triangle. Okay, now 3, I'm going to follow my steps here, supplement, find the supplement, that's 180. So think about it, it's 180 degrees, that's what supplement means. Okay, 180 of B1, and then call that B2. So what does that mean? So this is B2, this equals 180 degrees minus B sub 1, which is, of course, 47.6. So what am I actually going to do here? I'm going to go to Desmos. Watch what I do here. I'm just going to say B sub 2 equals 180 minus B sub 1. And that's what I get. Isn't that glorious? That's like straight up prime time exact answer. So 132.4, let's just round it there. So 132.4, let's go back. 132.4. This is my second angle of B. Okay, my second angle of B. Perfect. Again, this is B2, right? And because I want to make it all like nice, I want to make sure it looks all nice. Now, my fourth step, okay, my fourth step up here is going to be find angles C1 and C2 respectively. How do I do that? Well, you do it the exact same thing. So if I want to find C1, this equals 180 degrees minus, I already am given 40, so I can minus 40 degrees. That's my angle A. But then I minus B1. Okay, so I minus B1 so I can find what C1 is. That's what respectively means. So what does C1 equal? We're going to find that out. And then I do the same thing with C2. So C2 equals 180 degrees minus 40 degrees. And then minus, not B1, but B2. And this is going to be what C2 equals. That's what I'm going to do for my fourth step. And then, of course, I'm going to have my fifth step after that. Following along so far? So far, so good? I hope. So now let's go do that. 180 minus 40 minus B1. We'll find C1. Okay, so that means C1 equals, and I have 180 minus 40, and then minus my B1 here. So that's what my C1 equals. Now let's do C2, right, since we're already here, equals 180 minus 40, and then minus my B2. So isn't it cool that when you already have everything labeled on Desmos, you don't need to type in all the decimals? It's really annoying, right? You can just say B2 and then the calculator does it for you. It's rather fantastic. It's really great. So now what I really wanted to find was this. So 92.4, that's my C1, and then 7.6. So 7.6, 92.4. So let's go over here. So this one was 7.6, my C2, and then 92.4. Okay, and these are both degrees. Okay, I need to make sure that they're both degrees. Very, very awful, right? We're getting a lot of like doubles. So that's why I try to keep as much as possible, try to keep it in steps so you can kind of follow along. Now, step 5 is going to be as follows. Now I need to use what I'm given, so 54 and 40 for my A's. So I'm going to do 54 because I'm going to solve a proportion using the matching side angles, which was A. So this is sine of 40 degrees equals, and now I want to find my C's, right? My C1, C2. So I'm going to find C1 first, and then this is all going to be over sine of C1. Okay, so sine of C1, which is, I'm going to say 92.4 degrees. That's sine of C1. Okay, now when I solve this, I'm just going to be, when I solve this, it's going to look something like this. C1 equals 54. Actually, it's going to be the inverse, right? No, it's not going to be the inverse. It's not going to be the inverse because I don't need to solve for an angle. So it's going to be 54 times sine of 92.4 degrees, and then all over sine of 40. That's what it's going to be like. So what does this equal? Let's find out. Let's go over here. Let's do lowercase c1. So this equals, I'm going to do 54 sine of c1. Okay, that's what I'm going to do. And this is all going to be divided by sine of 40. Okay? So again, I could put in 92.4 whatever right here. That's C1. That's C1 right here. My angle, 92.4, 92.4. I could do that. It just takes a long time. Like I don't want to do that. So I'd rather just say C1. And so that is my C1 side length, not my angle measure, side length, 83.9. So 83.9, let's go over here, type that in, and let's hash out C2. So 83.9. So this is my side length. And then let's go to C2. So I'm going to use 54 all over sine of 40 degrees equals C2. Now, as I'm finishing this up, try to go to Desmos and see if you can do it yourself. Like, really try to do it. I'm actually going to do C2, which is 7.6 degrees. Okay, try to go to Desmos to see if you can do it yourself. Okay, but this is going to be C2 equals 54 times sine of 7.6 degrees all over, and then this is going to be sine of 40 degrees. Okay, I know it's kind of odd looking here. Okay, sine of 40 degrees. So go try to plug that into Desmos and see what you get. Pause the video even. So right now, I'm really just going to copy and paste it because the only thing that's different, guys, is just that this is going to be C2. And then I'm changing this to 2. That's literally the only thing that's different. So I can just copy and paste this, literally Control C, and then just Control V, paste that in here. And then it already calculates it for me. So what's my answer? Well, this is 11.1. So it's 11.1. Okay? That's C2. 11.1. Pretty cool, right? I think it's pretty cool. Okay, so 11.1. Let's go over here and type that in. All right, so now what you solved for is two triangles simultaneously. You made sure that it was two triangles. That was the check. And then afterwards, what you did was you essentially solve for one of your angle measures for B, the other angle measure but by the supplement, and then you solve for your other two angle measures for C, and then your other two angle measures or side lengths for C. Very complicated indeed. Now I will have a caveat before we go to the next example. Remember, guys, I will have a caveat though. This is it. Sometimes Math Excel doesn't give you A, B, and C. Sometimes they give you like C values. So this is like C equals, and this is lowercase c, and then that is B. So in that case, you would just follow your C's here. You would basically follow the exact same thing, but you would just replace the A's with the C, and you replace with the C's, and you would keep your B values. So you have to kind of do some changing. I know that's kind of confusing. Most of the time they don't do that, but sometimes they do, especially on honors questions. So just keep that in mind, that these don't always have to remain A equals, lowercase a equals, and B. Sometimes they do change it and give you C. It doesn't matter. As long as it's SSA, you have to understand that it will be an ambiguous case. If it's SSA, it will be an ambiguous case, and you do have to test something. Okay? Awesome. So this is actually what it looks like. To be completely honest with you, this is actually what it looks like when we go through it. So this is when you have two triangles right here. This is both of them together, both of them on top of each other. But really, our first triangle is this. Okay, we basically got 48. They rounded it here. They rounded these. I did exact values, but it's exact. It doesn't matter. This is 48 for B1, C1, and then C1. And this is your second triangle for B2, C2, and then you had C2 here. Okay? So this is why you have two different triangles, because you can actually implant this smaller triangle into that big triangle as such, which is what makes this case, the ambiguous case, the SSA, such a pain in the butt. Okay? Awesome. So that's just how it looks like visually. Last thing we're going to do is the formula for law of sines, the area formula for law of sines, and it's really easy. Okay, it's really easy. So if you don't know the height, but you have the SAS, the area formula of the triangle can be as follows. Of course, just your normal straight up area of a triangle. If you don't know the height, okay, but you have an SAS, the area formula for the triangle can be as follows. However, if you have something like this, an oblique triangle, you can straight up not just solve it like this, you can get a little bit more advanced and just solve it like this. Now, of course, just like with the law of sines, we're not going to use all of this. We're only going to use like one piece, okay, depending upon what we're given. We're going to be using only one piece or so, okay? It doesn't really matter. So I'm going to go through it. Make sure you actually write that down, though. Pause the video if you need to, and we'll get started on our last example. Perfect. So example 6, define the area of the triangle having two sides of lengths 24 meters and 10 meters, with included angle of 62. So we went around to the nearest square meter. What will this look like? Well, this, of course, is my formula, so I'm going to put that up here. Now, what will this look like? Well, it doesn't really matter which one I use, to be honest, because it doesn't really tell us this is A or this is B or whatever. It just gives us two side lengths and then an angle measure. So that's what we're going to be doing. So A equals 1/2. A equals 1/2. And then my two side lengths, so 10 meters, and then times 24 meters, and then times sine of my angle measure, which is 62 degrees. When I solve all this out, this will actually be 5 meters, and then times, these right here, 10 divided by 2 is just 5, times 24 meters, and then this, that looks gross, and then times sine of 62. And so I'm going to have you do that on the calculator. What you should get is 106.0 meters squared. Now, the reason why it's meters squared is because, of course, you have meters times meters. Sometimes they do give you a picture such as this. Okay, sometimes they do give you a picture, and so they give you B and C. So really, I guess what we're using is this one. Okay, that's really what that one that we're using, that formula. But it doesn't really matter, because as long as you have two side lengths and then one angle measure, if you needed to find the area, you could absolutely find the area, and that's how you would find the area. Okay, seriously, that's it. We're done with area. It's kind of odd having something that easy at the end of such a hard lesson, right? Okay, so what did we learn? Well, we learned a couple things, mainly just one thing, the law of the sines. Law of sines, how to solve oblique triangles, but we also learned the area. So how to solve a triangle, no triangles, and then the area. So the ambiguous case, how to solve just basic oblique triangles using the law of sines, and then, of course, how to find the area of an oblique triangle using the sine function. Sweet. Okay. Oh, I guess applied problems. I mean, they're all applied. Aren't they? Really, they're all applied. Homework quiz tomorrow, but again, this week is optional for the homework quiz. Thank you for sticking with me. I know it's a long video. In the titles, the title slides, I will have them embedded. So you'll see when you watch this video, when you go through the PowerPoint, I'll actually have the title slides embedded to the current URL time of YouTube. So you can kind of use that to skip around some of the examples. Okay? But until next time, guys, this is C Squared Mathematics. I'll see you guys later.